In this video, you'll learn why shear cracks develop near supports and how you can add reinforcement to avoid it. Shear is quite a complex topic. Still, to this day, I am learning new things about it on a regular basis. And it's shocking to me how many engineers I've worked with are unaware of the basic fundamental of shear in reinforced concrete structures. In this short article, I'll give an introduction to the most important basics, at least to me, of shear, why shear cracks happen and how we add shear reinforcement, so that, hopefully, RC elements don't fail in shear. Why and how do shear cracks develop in reinforced concrete beams? The best way to start understanding shear better is by looking at shear failure of RC beams, or in other terms, where the beam cracks when the shear forces are too big. Shear cracks of beams exposed to a line load appear as diagonal cracks near the supports. Why at the supports? Because that's where the shear forces are the biggest. Let's dive into why this is. This line load leads to a bending moment and a shear force when we cut the beam close to the supports. The bending moment leads to normal stresses with compression in the top and tension in the bottom, while the shear force V leads to a shear stress distribution which is zero at the outermost fibers and has its maximum value tau max at the centroid of the cross-section. The shear stress tau max at the centroid is equal to the principal stresses. You might have already seen now why we get the diagonal cracks. The principal tension stresses sigma I basically pull the concrete apart. How do stirrups avoid shear cracking? Alright, to solve this issue of diagonal cracking, we add stirrups. These stirrups basically help hold the beam together. Now, the beam can actually take up tension forces vertically. This means that we can use a strut and tie model, truss model to transfer the vertical loads to the support. With this strut and tie model, the stirrups have to be designed to resist the vertical tension forces and the concrete needs to be checked for the compression forces of the struts. Hope this explanation helped understand shear a bit more. Writing this, I researched a lot and learned a bunch myself. In structural engineering, there is always more to know.